When you have a radius and a diameter that meet a tangent line, something special happens. You get a 90-degree angle. It always works, doesn't matter where it meets it. Just pretend that you have a wheel that's on the road. You want your car to be upright. So straight down is going to be 90 degrees with that. Okay. And that applies to any radius, diameter, meeting a tangent line on the outside. They're going to be perpendicular. That symbol for perpendicular is an upside down T, and it's two lines that form right angles. Knowing that, we're going to be using right angle stuff. So you know where that's going. It's going to be involving triangles and Pythagorean theorem and in some cases trigonometry, although we won't use it in this example set here. So for example 3, we want to know that what AB and BD is. We are given that BC is tangent. So since BC is the one that's tangent, that means the right angle will be formed right there. Now, if I want to get AB, well, that's just the hypotenuse of a right triangle. That's going to be a squared plus b squared equals c squared. So 12 squared plus 5 squared is going to be 144 plus 25. And then you can square root both sides. The square root of 169 will get you 13. So I know C is going to be 13. That means AB is 13. Now, as far as getting BD, well, you have to understand what a radius is. A radius doesn't just go where it's drawn. A radius can be any point from the center to the edge of the circle. A radius will never change in a circle. So if that 5 is the radius here, then that will be 5 as well. So you have to assume that that's going to be carried over here. So if I want to know what BD is, I'm going to subtract 13 minus 5. That's going to give me 8. So 5 plus 3 is 8 plus 3 is 13, and that fits in the Pythagorean theorem here. All right, guys, try letter B. It's pretty similar, just kind of, they give you this segment instead of the radius. So pause the video and give it a try on your own. Okay, in this problem, I have XW. Now, I don't know what that is, but that is my radius. I'm going to call it R. It says YW is tangent. YW is tangent. That means the right angle will be here. So my hypotenuse is 25. So my setup is going to be R squared plus 24 squared is equal to 25 squared. All right, let's do a little calculator work here. I know 24 squared is 576. 25 squared is 625. I will want to then subtract 625 and 576 to get that solved for R squared. So R squared will equal 49. And then we can take the square root of 49, which is 7. And I have my radius. So that translates into this being 7 for XW. Well, if I know the radius is 7, then XZ is also going to be 7 because that's a radius as well. And then I can get ZY by doing exactly what I did to end the last problem, subtracting your hypotenuse and the radius. So 25 minus 7 will get you 18. All right, let's look at example 4. I'm gonna clear this off. This one's a little bit trickier, so pay careful attention. I don't have a second one on here for you. So in this problem here, we have RT is tangent to a circle. Therefore, RT is going to form a right angle with this radius. We are only given this outside portion, not the hypotenuse. So we have a little bit of work cut out for us. What we do know is that the radius is going to be the same. So I'm going to call that R. I'm going to also call this part R. Now, the Pythagorean theorem says a squared plus b squared equals c squared, but my c is the combination of the R and the 9. So when I set up my formula, it's going to look like R squared plus 15 squared is equal to the sum of R plus 9 squared. Well, that's going to involve some algebra. So if you remember, if I'm trying to multiply R plus 9 by itself, aka square it, I'm gonna have R squared, 9R, 9R, and the 9 times 9 is 81. So that's actually gonna combine to give me R squared plus 18R. Remember, we double that 9R, 9R plus 81. 15 squared is 225. Let's double check that. So I'm going to rewrite that as 225. Thankfully, on this problem, we have R squares that'll just cancel out. So I don't want those R squares anymore. Let's cancel those out. And let's solve the equation without the R squares. 225 equals 18R plus 81. Definitely manageable. Subtract the 81 from 225. I believe that's 144. And then we'll divide that by 18. So we have 144 equals 18R. 18 goes into 144. How many times? 8. So your radius in this case will be 8. How do you know if that's right? You can double check that work. So if I know my radius is 8, let's go ahead and circle that. I know that's right. I'm going to go back into my triangle. And I'm going to plug in 8, okay? I'm going to say 15 squared plus 8 squared. And the right side would be 8 plus 9. Well, 8 plus 9 is 17. So if I square 17, you'll see 289, and you'll also see 289 right there when I did 15 squared plus 8 squared. That tells me it fits in the Pythagorean theorem. It's true. Your radius is going to be 8, which means your diameter would be 16. All right. Now, before we get into the next video, I want to show you, well, I want to show you this formula here. And this problem can be done utilizing Pythagorean theorem. But I'm going to show you a shortcut, show you why that formula is going to be on there in the next video. And there's additional formula on the next page that I'll put in that same video, kind of along the same lines as this one. So thanks for watching this video. Stay tuned to our last one to get the outside segments in the circle.